Hey guys, welcome to another online math class. This video will be about the line of best fit. And by the end of this lesson, we should be able to fit one by eye, be able to find the equation of a line of best fit, and finally be able to use the line of best fit and its equation to make predictions. Let's just pause the video here and take a couple of minutes to write these down. So a line of best fit, also commonly known as a trend line, is positioned by balancing the number of points above the line with the number of points below the line. And you also need to consider the distance of each point from the trend line. So having a look at this scatter plot, we're going to have a go at fitting a line of best fit. So firstly, it says we need to balance the number of points above the line with the number of points below the line. So we need roughly the same number of points above and below it. We also need to consider the distance from the line, and that has to be very similar as well. Let's try and draw a line. Just get a ruler, draw a rough line that has about half the lines above it and half below it. So that's not the best one because I don't have a ruler. But if you did it properly, that is something you should have. So if you count the dots, we have 6 above it, we have 5 above it, 2, 4, 5, and we have 5 below the line as well. So we have the same number of points both above and below it, with the line being right in the middle of all those points. So that's how we fit a line of best fit. Let's try another one. So we've got this one here. Once again, I need about half the lines above the line and half below it. And if you draw it incorrectly, that is something you should have there. So if you count them up, it's not exactly half above and half below, but that is about the best we can do with the dots given. And you will get full marks for a line that is very similarly placed with that one. And let's try one final one. We have this here. So just get a ruler, try and draw a line that's halfway in between there, and you'll get something like that. So these line of best fits don't have to be completely accurate. Alright, let's have a go at a question here. It says draw a scatter plot for this data first. So we did this in our last lesson quite a bit. We're going to plot each of those points down. So our first one is 1, 1. Next one is 2, 2. Next one is 3, 2. That's there. Next one is 4, 3. Just up there. Next is 5, 4. Next is 6, 4. And last one is 7, 5. So that's our scatter plot. Question B says, is there positive, negative, or no correlation between X and Y? I'd say that's positive. That looks like a straight line. And it's going up from left to right. So question B will be positive. Now question C, fit a line of best fit by eye to the data on the scatter plot. So once again, just get a ruler and draw a line that's about halfway in between each of those points. And that is just a nicer version of the line to look at. Alright, now we're going to use our line of best fit to do question D and make some estimates. So this one says predict what Y is when X equals 3.5. So let's go to 3.5. And it's got it in the dotted line for you, and that's going to be my Y value there. So my Y value is going to be roughly around 2.7. So for I, I'd write about 2.7 there. Alright, part 2, Y when X equals 0. When X equals 0, Y is estimated to be about 0.4. For part 3, X when Y is 1.5. So this time I'm going to where Y is 1.5. And X is going to be roughly around, I'd say about 1.7 there. And part 4, X when Y equals 5.5, so that's up here. X value is about 7.8. So that's how I'd use the graph to make some predictions. Alright, now it's your turn. Pause the video here, have I got these ones by yourself, and just unpause it once you're ready to go through it with me. Alright, so once you've plotted each of these points, this is roughly what you should have for the scatter plot. Give yourself a tick if you got that correct. And part B, is there a positive, negative, or no correlation? This looks like a straight line and it's going down from left to right. So I would say there is a negative correlation there. And part C, fit a line of best fit by eye. So you get a ruler, try and get about half above and half below. And you should have a line that looks something like that. Once you've got the line of best fit, we're going to use it to make some predictions. So let's predict what Y is when X equals 3.5. So X equals 3.5 is around here. So I'd say Y is about 7. So that's part 1 there. Part 2, Y when X equals 0. When X equals 0, Y is about, I'd say about 11. So I'm using these squiggly lines because it's not an exact value. X when Y equals 1.5. So Y equals 1.5 is around here. I would say that's around there. So I'd say about 9.1. And part 4, X when Y equals 5.5. That's around there. So I would say this should be an X, I'll fix that up. That should be X is around 5. Alright, so give yourself a tick for each one you got correct there. Now moving on to the next part. Once we've got a line of best fit, we can also find an equation from it. So we'll do this by using 2 points on the line of best fit. Using the 2 points, using this equation here, remembering that from linear equations and graphs, we can find the gradient. So that's m. Once we've found m, substitute that value back into here and a point on the line, and then we got c by itself, and we can solve for c. Let's have a go at doing that with an example question there. And this is the example question we'll be working with. So this scatter plot shows a linear relationship between English marks and literature marks in a small class of students. A trend line passes through 40-30 and 60-60. So we need to find the equation of the trend line. It's given us the 2 points to work with. So remembering our formula from before, m equals y2 minus y1 over x2 minus x1. You might want to write that down just so you don't forget. So I'm going to call this x2, y2. I'm going to call this x1, y1. So the order doesn't really matter here. You could have called this one x1, y1 if you really wanted to. So y2 is going to be 60. Y1 is 30. X2 is going to be 60. And x1 is going to be 40. That gives me 30 over 20, which gives me 3 over 2. So therefore my m value, 3 divided by 2, you can put that in the calculator, but that will give you a value of 1.5. But you can keep it in the fraction as well. You can keep it as 3 over 2. So far I've got y equals mx plus c. That's my default equation for a linear equation or a linear graph. And my m is going to be 1.5 or 3 over 2. You can use any of those two values, and that gives me y equals 3 over 2x plus c. Once you've done that, you're going to pick any of these values. You can pick either 40-30 or 60-60 and put it back into that equation. I'm just going to pick 40-30 because it's small numbers, and small numbers are generally easier to do calculations with. So my y value is going to be 30. My x value is going to be 40. Now I've got c by itself, so I can solve for c. So first thing, you're going to do the calculations that you can. So you're going to do 3 over 2 times 40 first. Just put that straight into your calculator, just to ensure that you don't make any errors. So just put 3 over 2. You could have used 1.5, doesn't matter too much there, times 40, and that gives me a value of 60. So I end up with 30 equals 60 plus c. Once I've got that, I need c by itself, so I need to subtract 60 on both sides. That gives me negative 30 equals c. Once you've got that, you're going to substitute that back into here. So therefore my equation is going to be y equals 3 over 2x minus 30. So that's part A done there. So our next part is to use our trend line or that equation to make some estimates or predictions. And that's what a line of best fit is really used for. So predictions within the data range is called interpolation. And that's just within the smallest value and the largest value. So anywhere in between there, that's interpolation. Extrapolation, on the other hand, is outside the data range. So if you had a prediction like maybe out here, or maybe even up there, that's outside the data range. It's not as reliable, but it is still used for that. And that is called extrapolation. So let's have a go at making some predictions. Question B, use your equation to estimate a literature score if the English score is 50 for the first part. So having a look at the graph, literature is the y, English is x. So that means I'm trying to find y. So I'm going to substitute x with the English score, sorry. That's going to be 3 over 2 times 50 minus 30. Once you've got that, just chuck that straight into your calculator. And that's what your calculator should look like. 3 over 2 times 50 minus 30. Press enter and you get 45. So if the person gets 50 on the English score, they're most likely to get 45 on their literature score. And now part 2. Let's have a go at that. It's the same deal here. We're just going to replace that 50 with an 86 this time. So I get 3 over 2 times 86 minus 30. And once you work that out, that is what your calculator should look like. Just press enter and you get a value of 99. So the predicted score for literature, if they get 86 on English, is going to be 99. Now part C, we're going the other way. We're using the literature score to estimate the English score. So that means we're going to substitute different values. So part C, I'm still using that equation, but I'm given y. So that means 42 equals 3 over 2x minus 30. Once you've got that, I need x by itself, so I need to add 30 to both sides. That gives me 72 equals 3 over 2x. Now I need to get rid of the 3 over 2, so I'm going to divide 72 by 3 over 2. And that's what your calculator should look like, so you get a value of 48. So if they get 72 on literature, they're likely to get 48 for English. And part 2 of that question, so that was part 1. Part 2, exactly the same thing, we're substituting 87 this time. Gives me 87 equals 3 over 2x minus 30. Add 30 to both sides, that gives me 117 equals 3 over 2x. And once you work that out, your predicted English score will be 78. Just make sure you're writing those answers out in words though. Alright, now it's your turn. Pause the video here, have a go at this one by yourself and just unpause it once you're ready to go through it with me. Alright, so first step, finding the equation of the trend line. So remember, I need to use this formula, m equals y2 minus y1 over x2 minus x1. So I've got my values here. I'm going to call this x2 y2, I'm going to call that x1 y1. So y2 is 70, y1 is 20, x2 is 40, x1 is 10. That gives me 50 over 30 or 5 over 3. So you can convert that into a decimal, or you can just keep it as a fraction. So far I've got y equals 5 over 3x plus c. Once I've got that, just pick any of these two coordinates again and substitute it back in. So remember, we read coordinates, x first and then y. So my x is going to be 10, so I have 5 over 3 times 10 plus c. My y is going to be 20. Once you've got that, just put that into your calculator. So 20 equals 5 over 3 times 10, like so. Press enter and you get 50 over 3. So that means 20 equals 50 over 3 plus c. And because there's no sign in front of that, that means it's a plus. So I'm going to subtract 50 over 3 from both sides. So I'm just going to do 20 minus 50 over 3. Let's put that into the calculator. Press enter and you get 10 over 3. So that means 10 over 3 equals c. So I'm just going to keep that as a fraction. So I've got my full equation now. I've got y equals 5 over 3x. And that's my c. So I get plus 10 over 3. Give yourself a tick if you got that correct. Now moving to question B, making some predictions. I'm going to use our equation to estimate a dog's height if its mass is 25 kilos. So mass is on the x. So I'm going to replace x with the given value, in this case 25. So that's what I got. Once you're here, you just chuck that all into your calculator so you don't make any errors. And that is what your calculator should look like. And just press enter and you get 45. So just make sure you're writing your full answer in words. So your answer will be 45 centimeters. So what this means is if the dog is 25 kilograms, it is predicted to be 45 centimeters in length. So give yourself a tick if you got that correct. Now part 2, we're just going to substitute 52 this time. So that gives you y equals 5 over 3 times 52 plus 10 over 3. And then put that straight into your calculator again. And that is what your calculator should look like and gives you an answer of 90. So if the dog is 52 kilograms, it is predicted to be 90 centimeters in length. Now moving to part C, going the other way, we're predicting the mass this time, once given the height. So the height is 60 centimeters, so that means y is going to be 60. And I'll just put in the rest of the equation. I got that from here. We're trying to find out what x is this time. So starting off by subtracting 10 over 3 from both sides, because I want x by itself. And that's what you should have in the calculator. So 60 minus 10 over 3 gives me 170 over 3, and I'm left with 170 over 3 equals 5 over 3x, because 10 over 3 minus 10 over 3 equals 0. Once we've done that, I just do 170 divided by 5 over 3, because this means 5 over 3 times x. The opposite of 5 over 3 times x is 5 over 3 divided by x. So we do that on both sides. Just put that into your calculator again. So 170 over 3 divided by 5 over 3. And that gives you a value of 34. So x is going to be 34 here. So that means if the dog is 60 centimeters, it is predicted to be 34 kilograms. That's part 1. Now part 2. Same thing here, except we're replacing y with 80 this time. So That's now my equation. And once you solve that following the steps like we did before, you'll get a value of 46 kilograms. Give yourself a tick for each one you got correct there. So that brings us to the end of this video. Thank you guys for watching, and I'll see you guys all back online.